The rise of artificial intelligence, particularly deep learning, has been significantly accelerated by advancements in hardware. While CPUs, central processing units, have traditionally been the brains of computers, GPUs, graphics processing units, have emerged as powerful accelerators, especially for training and running complex AI models. This explanation will explore the reasons why GPUs are so important in AI, highlighting their strengths and contrasting them with CPUs. Why GPUs are essential for AI, parallel processing powerhouse. CPUs are designed for general-purpose computing, excelling at sequential tasks. They have a relatively small number of powerful cores. GPUs, on the other hand, are built for parallel processing. They contain thousands of smaller, specialized cores designed to perform the same operation on multiple data points simultaneously. Many AI computations, especially in deep learning, involve numerous independent calculations that can be parallelized. GPUs are exceptionally well suited for these tasks, offering a massive speedup compared to CPUs. Imagine a CPU as a skilled chef, meticulously preparing a complex dish step by step, while a GPU is like having a kitchen full of cooks, each handling a different part of the preparation concurrently. Matrix multiplication maestros. Deep learning relies heavily on linear algebra, particularly matrix multiplications. These operations are fundamental to how neural networks process information. GPUs are specifically designed and optimized for matrix operations. Their architecture allows them to perform these calculations much faster than CPUs, often by orders of magnitude. This speed boost is critical for training large neural networks, which can involve billions of parameters and require countless matrix multiplications. Memory bandwidth. Bonanza. Training deep learning models involves moving vast amounts of data, weights, activations, gradients, between the processor and memory. GPUs have significantly higher memory bandwidth than CPUs. This means they can transfer data much more quickly, avoiding bottlenecks that can slow down computations. Think of memory bandwidth as a highway. A CPU has a narrow two-lane road, while a GPU has a wide multi-lane superhighway, allowing data to flow much faster. Training time. Transformation. The combination of parallel processing, optimized matrix operations, and high memory bandwidth translates to a dramatic reduction in training time. A model that might take days or even weeks to train on a CPU can often be trained in hours or even minutes on a GPU. This speedup is crucial for researchers and practitioners who need to experiment with different architectures, hyperparameters, and datasets. It allows for faster iteration and development cycles. Scalability for complex models. As AI models grow larger and more complex, the computational demands increase exponentially. GPUs provide the necessary scalability to handle these increasingly sophisticated models. Multiple GPUs can be used in parallel to further accelerate training, enabling the development of even more powerful AI systems. When are CPUs still relevant in AI? While GPUs dominate deep learning training, CPUs still play important roles in AI. Inference on mobile and embedded devices. CPUs are often used for running, inferencing, pre-trained AI models on devices with limited power budgets, like smartphones or embedded systems. Pre- and post-processing. CPUs are often used for tasks like data pre-processing, feature engineering, and post-processing of results, even in GPU-accelerated workflows. Specific AI algorithms. Some AI algorithms that don't heavily rely on matrix operations might not benefit significantly from GPUs and can be efficiently run on CPUs. GPUs have become indispensable for AI, particularly in deep learning, due to their parallel processing capabilities, optimization for matrix operations, and high memory bandwidth. While CPUs remain important for general-purpose computing and certain AI tasks, GPUs have revolutionized the field by enabling the training and deployment of complex AI models that would be impossible to handle with CPUs alone.